Hello, everybody. Our project is an image classification model maker called Paradolia. My name is Armando Vega.
My name is Alexangelo Orozco Gutierrez.
And my name is Rudy Cacho Hernandez.
Now, a little background on our project. Now, machine learning is a rather complex and intimidating topic for many, especially those who aren't developers or who are not as privy to this topic. And existing platforms who offer services to mitigate this are not all in one solutions. Maybe they're missing the data collection aspect of it, or maybe they don't offer full evaluation tools for users to use.
So, our motivation for our project is that we want to educate individuals on the process of creating an image classification model. We also want to make the data collection process simple and pain-free to organize that data, and in addition, keep the data that they collect for themselves so that they don't have to share it or put it in like another database for other models to get trained off of. As for our objective is to provide the users new to machine learning the tools to train and evaluate the performance of the model. Have one place to collect the data and inference it. And finally, we want it to be automated so that the user doesn't have to do any prior setup or have any prior knowledge.
Approach. So our approach on developing this app is that we want our desktop app to be multi-platform, meaning Windows and Mac OS. We want our mobile app to also be multi-platform, meaning iOS and Android. And we want both of these types of applications to have network connectivity so that they can transfer the necessary files from and to each other. The technologies we use to make all of this happen is PyTorch and TensorFlow for the training pipeline. These are frameworks for machine learning. We also have LightRT for continuous inference. LightRT is a mobile framework in which our models get converted to for mobile use. We have our Electron and Node desktop GUI. This makes it easy to make a program for macOS and Windows, as well as have easy access to the file managers. And we have React Native mobile application, which allows us to develop for iOS and Android seamlessly without having to worry about two different code bases.
Now, for the methods of how we're going about this, the mobile side will mainly deal with data collection and population via video taking. And once the user is able to populate their data sets on their mobile device, they can upload these videos to the desktop side for frame extraction to get all the photos from their videos. We also have the desktop application use a split machine learning framework training pipelines between PyTorch and TensorFlow, and overall um, allowed for um, seamless data transfer of files between the mobile and desktop side for dataset upload and model profile download.
As what we've changed from our original plan is that previously a project was had both data sets and models, so we separated that so that multiple data sets can be used for multiple models. We added a PyTorch framework for user choice, as well as we simplified the connection process between our mobile and desktop app by using an API rather than a peer-to-peer connection.
Right here is our mobile application. We can see that we have a datasets tabs. We can see several datasets. And in this case, we chose bananas. We can record a video for bananas to then store in the bananas dataset. And from here, we can view the videos and choose which ones we want to upload to the desktop app. The way we approach connecting to the desktop app is by using a QR code scanner. The desktop app has a QR code, and the mobile app can scan it to get the local IP address for easy connectivity.
And that brings us to our desktop application. So if you divert your attention on the main menu to the bottom left is our QR code, which you can scan from the mobile side to establish that API connection to the mobile side. Above it is our sidebar navigation tab, which is the main way of navigating through the app between the model and data set profiles that you've created. Here is the model creation page. You can either start from scratch or use a pre-trained model to create your model. Here is the main training page. On the left side, you are able to assign datasets to your particular unique labels. If you have multiple datasets that fall under one particular label, you can assign it in this area. On the bottom, there are several training functions. If you want to switch back to starting from scratch or back to a pre-trained model, you're able to do so there. And with our particular frameworks, you can switch between TensorFlow and PyTorch. On the bottom right, you're able to adjust the epoch number for how many iterations you want to train your model for.
Here we have our block builder modes for when the user wants to create their own sequential model from scratch. On the left, they have the various layers to choose from with a hint at the bottom about what it does. In the middle, they drag and drop the blocks from the left to the right, and then they can also edit the properties if they click on it. And here we have the editor view of the model builder, which is interchangeable. So if you edit from one side, you can go to the other. And it is provided for more experienced people to be able to edit easier and as well as easy sharing since you can just copy and paste this and send it to other people as well. And as we return back to the main training page, once the model is trained, the user can now send their model back to the mobile app to use for live inferencing through the same QR code connection.
And what that looks like on the mobile side, if you see on the image on the left, you have the importation tab in which you can see all of the models that you get from the desktop side. Download the particular model profile that you want. As you can see in the middle image, we can get our fruit model and use it for live inferencing on the very right. As you can see, we can identify the fruit of our choice with this fruit model.
Future work. Some things we would like to do in the future is make a cloud compute program, which would allow for collaborative access, would allow for faster training when the hardware doesn't support it, and would also allow for use of just a mobile phone in the case where someone may not have a desktop. Another feature is more training metrics. This may be more ways to test out your model, more ways to inference, and overall make sure that your model is more tidied up. And we have data collection collaboration. This includes being able to see who added what images to a certain data set, and also being able to rank which images are good images so that you can make your model the best it can be. So to conclude this, we have our fully functional desktop and mobile workflow with mobile data collection, desktop model training, and training process guidance. This allows a user to be able to operate all of these things without needing to know much, if any, programming principles.
Some acknowledgements. We would like to thank Dr. Drew Klinkenbeard, our mentor, for his overwhelming support in our project and our endeavors. We'd also like to express thanks to Dr. Sam Ogden for his extensive machine learning knowledge and insight in completing this project. Thank you.
Thank you.
Thank you.